This question is called joint default probability. It says if there is a 50% probability that bond A will default next year and a 30% probability that bond B will default, what is the range of probability that at least one bond defaults, and what is the range of the correlation? So it's saying when it says at least one bond will default, we're going to look for the probability of A or B, of either one defaulting, of one. And that is the probability of A plus the probability of B minus the probability of A and B. Now in this equation, probability of A and probability of B are constants. They're given to us right here. Probability of A and B is what can vary. So when it says at least one, we can break that up into two different possibilities. So probability of A and B can be split up. Either the bonds are disjoint, as in it's impossible for them to both occur, or they are fully overlapped, as in one occurring will cause the other one to occur as well. So both occurring events, aka the probability of A and B, must fit into both A and B, their individual probabilities. And so that means that the probability of A and B in this case is the minimum of 0.5 and 0.3. And so it's equals to 0.3. And now in the disjoint case, where they cannot both occur at the same time, then the probability of A and B must be equal to 0. Now we have to find, now we plug these into the probability of A or B. We get probability of A plus probability of B, so probability of A was 0.5. Probability of B was 0.3. And in this case, probability of A and B was 0.3. So in this case, it's 0.5. In the other case, it's going to be 0.5 plus 0.3 minus 0. In this case, we get 0.8. And so the range of probability of both defaulting is 0.5 to 0.8. And now what about the range of their correlation? The correlation equation is the covariance of A and B over the square root of the variance of A times the variance of B. Now, for the covariance, we get it equals the expectation of A and B minus the expectation of A times the expectation of B. So the expectation of A and B can be broken up into the probability of A and B times 1, because the outcome of this event, or the outcome in this case is 1, right? We either occur or don't occur. So it's either 0 or 1. This is the values of our support. So with probability of A and B, we occur. With probability of so 1 minus probability of A and B, we don't occur. So this means, since we're going based on occur and don't occur, we can replace the expectations in this formula with just the probabilities. Because as you can see, with some probability of A and B, you occur, otherwise you don't occur, which is 0, so it just cancels out. This can be applied to the expectation of A and expectation of B as well. I'll show you, for example, in this case, we'll have probability of A, we occur, with probability of 1 minus probability of A, so otherwise we don't occur. This cancels out as well, so you have probability of A left over. So we can say the covariance of A and B is the probability of A and B minus the probability of A times the probability of B. Probability of A and B could have been, we said, 0.3 minus 0.5 times 0.3. So in this case, it's going to be 0.15. Otherwise, it was 0 minus 0.5 times 0.3, which equals negative 0.15. And that is going to be our numerator. So just going to say plus or minus up here. And down here, the variance of A is going to be the probability, for a Bernoulli distribution, where you either occur or don't occur, so 0 and 1. You say the variance of A is going to be the probability of A times 1 minus the probability of A. Probability of A was 0.15, sorry, 0.5. So we say 0.5 times 0.5 equals 0.25. Did I put the square root here? Yeah, I did, okay. Square root of 0.5 times, now for the other case, variance of B, so other bond, we get probability of B times 1 minus probability of B. So we get 0.3 times 0.7, which is 0.21. So this is 0.25 times 0.21. And so we get 0.15 divided by square root of 0.25 times 0.21. So we get plus or minus 0.655, and that's going to be the range. So negative 0.655 to 0.655. And that is our final answer for part B, and part A was right here.